Alright, we're back. And the topic today is force and the different types of forces. So first things first, we made our own little track here, our own kind of roller coaster with a loop-de-loop. And just kind of give you the idea of what's going on with that, give you the raw statistics first. So we have the top hill, our total drop height was 68 centimeters. The vertical drop from the top of the loop, so when we're up the top, to the base was 43 centimeters. The diameter of the loop was 25 centimeters, and the total length of the track, correct me if I'm wrong, Paul, was 53 centimeters.
53 times 5.
Times 5, so each, yes, of those is 53 centimeters, sorry. So we tested 3 different types of marbles. We had the blue marble, which was 14.4 grams, the green, which was 18, and not technically a marble, but a round piece of wood, which was 5.8. And then we ran them through the track. And the blue took 1.32 seconds, the green took 1.38, and the wood took 1.31. So, not a whole lot of difference there.
Galileo was still right.
Yes, yes. So we tweaked our track many times, finally got things to work where they would actually finish their run through the loop.
Big problem always was it would hit the joining piece and fly off, and that was just a pain.
Right. But, so even with our little track, we kept going back to the idea of a roller coaster. It was something we could all mostly relate to, and the forces that go on with that. So, moving on to the misconceptions, so what our little experiment addressed, the many things it addressed.
Well, we had a couple misconceptions in mind. The first one we were dealing with was the forces and the directions that they are in. I guess the sub-misconception of that we talked about was centrifugal force, because most students feel that they're being pushed out, so they think the direction is outwards, where it's in, towards the middle of the circle. And then the other one was a conservation of energy.
And I also think another one is they all might think that gravity is the winning force, because gravity's always there.
Yeah.
But if gravity is the winning force, your roller coaster ride would suck.
That's true. So those are our misconceptions. How our investigation kind of addressed those. So, I mean, how good have we
Let's pause for a second.
state this?
So what you see here is sort of a little diagram and an animation that we found demonstrating a roller coaster, and it's basically showing the force vectors, or what force is acting on it. Whenever the marble, it's basically showing that, basically it's proving Newton's first laws and second laws, as well as sort of the third law, is basically because gravity's always acting, it's because the roller coaster's never in contact with the earth, so there's no counterforce to gravity. There's a counterforce from the car on the track and the track back up in the car. And that's sort of why you get the push back in. The direction of the force is actually into the center of the roller coaster loop, not out, despite that's what you feel. That's probably more of a relativity momentum thing. There's also, and you can see sort of how each one, as it goes around on each side, it's sort of saying, because net forces always act in the same way, that's sort of going to be the direction of your velocity or your cart. Pause right there. Back to energy.
Alright, so addressing the misconception of energy, we were tweaking our roller coaster like what we said, because it wasn't working. The marble wasn't going quite around the track the whole way. So when we made the height, we were adjusting the height, we had to make sure that the loop wasn't higher than that, or else the conservation of energy wouldn't equal out. We would lose it.
even though we're not supposed to talk about it, it's because momentum is a form of energy.
Yeah.
Right, it's something
So-
that, yeah.
So yeah,
That's-
students
that's
would
next
come
week.
across that. Yeah.
Yeah.
Mm-hmm.
And this is also probably one instance where actually I think velocity is probably the more useful measure because we have distances, we have times. You can't really measure accelerations per se, but we do have masses, so
Right.
the units still work.
Yes. And just a little tidbit of information here, referring to the loop and kind of how we restructured it, and relating it back to roller coasters as well. They used to have more of a round loop back in the day on roller coasters, but it required a lot more force to make that in a complete circle, which could be a little uncomfortable. So that's when they went to the more of the teardrop shape, which is kind of what we made with our track after a little bit of tweaking, and that balanced out the forces. So there's a little bit more force going in, and then, you know, when you're at the top of the loop, which is everyone's favorite part, you feel nice and light. That has much less force, and then comes right back around. So you've got a lot of force on the sides, not as much, balances it out, so you're not feeling totally crushed when you go through that loop. So.
And again, it's app incompatibility, so you can actually see the roller coaster, a few attempts at it separately in slow motion. That's us, the slow motion group.